Welcome back to another video. My name is Derek. Today we're going to be taking a look at how to modify an iPhone to have a dual SIM card reader. And the skills that I hope to convey are going to give you the ability to do things like replace a SIM card tray, even if it isn't a dual tray, as the trays do go bad. So knowing how to replace it is a good idea. Also going to be showing you how to reball the mid-frame. And being able to do that serves for many different purposes in restoring Wi-Fi, Bluetooth, cellular, having to work on water damage, and a bunch of other things. We're going to dive a little bit into the schematics and board view, tips and tricks on how to micro solder, and the new technique that I've found works best for me to install the micro jumpers to connect the circuits to activate the second SIM. So watch through the entire video so you don't miss out on anything. Let's get started. Alright, the owner of this iPhone 13 would like for me to take it from a single SIM to a physical dual SIM, so that's what I'm going to do. We'll start by powering off the device. This one's already been opened, so it's pretty much ready for me to take the motherboard out and get going. Like even with my nails, I can pop it apart. We'll disconnect the battery, disconnect the display, and I'll show you the process that I go about doing this. So we'll set aside the screen and the battery, and I'm just going to take a second to disconnect every single flex cable from the motherboard. I'll disconnect the 5G antenna. And as I go about this, I just want to make sure that I'm not missing anything. And this one is always a little trickier because it's so far down in there. All right, now that everything is disconnected, I'm able to pop out the motherboard. We'll set the housing aside and we'll turn our attention to this pristine motherboard. No one's touched this before. I'll be the first one to handle it. I'm going to take some isopropyl alcohol and I'm going to add some drops to all of the padded foam connector stickers. This will help me pop them away without damaging them so I can put them back unharmed when the time comes. Just take my tweezers, get under the adhesive. All right, so we've got all of these saved. I'm also going to carefully pop off the water damage indicator. There's a little plastic piece along the single SIM reader here that will pop off. We'll flip this around, and on the back side, I've got this graphite thermal sticker that we need to remove. I'm going to take my time to carefully get all of the sticker up so I can peel it away without it shredding, because if you break up those layers, it'll just come apart, and then it'll be annoying to put back later because it won't want to sit flat again. So we'll take that and we'll set all of this aside for later. All right, so I'm going to take a board heater now. I'm going to go ahead and turn it on, and I like to set mine to 205. That's where I like to take the 13 Pro Max motherboards. When we go and put it back together, we're going to be reballing the mid-frame, and I'm not going to take it up that high because we're going to be dropping from like a 185 to a 150 solder paste. As this warms up, what I'm going to do is take this standoff screw holder, and this will actually help me in lifting the top board off. I'm going to line up the motherboard, and then I'm going to take these little arms, and they'll pin down the motherboard in a couple spots, making it so when I go to lift this up, it doesn't just lift up the bottom board with it. All right, so we're almost to temperature. We're about 200. So now I'm going to start to kind of probe around the board and see if we've got any movement. What I'm going to do is I'm going to take the blade here and I'm going to give it a little insert and a twist to see if we've got any separation. You can see there's a little bit of movement between the sandwich layers there. And I'm not going to move it crazy because I don't want to warp. There's the beep. That tells me I'm at temperature. So we're going to sit here for a minute as I go around kind of probing, see if we get the movement I need to lift the board. You can see how it just lifted there. And I'm going to come around the back side here, and we're going to do the same thing. Insert, twist. And now that I've seen motion basically everywhere, I can come in and I can pop this off and set it aside. And then we'll go ahead and turn this off. And while it's nice and warm, I'm going to take my wick and I'm going to get a step ahead, and I'm going to go around the border and we're going to wick up all of the edge getting rid of all of that solder. It's easier to do this when it's hot than to do it when it's cold. All right, we'll take it off and gently set it down and let it cool down and set this aside. One of the few things that I'm going to do to the top is I'm just going to get rid of all of this heat sink. If I don't remove it, then it could create a high spot, causing kind of a teeter-totter effect when I comes to putting the sandwich boards back together. So I'm going to remove any chance of it having that happen, and I have never seen any issues from removing the thermal paste. And we'll do the same thing on the bottom. We're just going to gently go in and scrape up. It comes off relatively easily in big chunks. I'm going to get a Q-tip and we will soak it with some alcohol. And then this area I'm going to be working on, it's got a bunch of that thermal paste residue on it, so I want to clean that up, and that way when we work on that area we're not competing against the black stuff. Now I'm going to flip over the motherboard and I'm going to stick it in my Omnivice. So I've clamped it in my Omnivice here because we're going to remove the single SIM tray. We'll turn on my rework station and I'm going to quickly take this off. So I've got my hot air set to the max basically on everything. It'll beep until it's up to temperature. And in the meantime, I'm just going to heat up this area, put a little bit of tension on the SIM tray. And when it's ready to let go, it'll just basically fall off. We'll heat up the area, and there it fell off. Now I'm going to take some flux, and we will hit the solder joints that are visible there. Come in with my soldering iron, and we're going to try to wick up while it's still hot the solder. Sometimes you get quite a bit of it. Depends on how fast you are. Doesn't look like I'm getting as much as I want. So I'm going to cut here, stick that there, get some more flux to kind of flood into the wick there. I turn my airflow way down, and we're going to put the temperature just above 400 there. And then I'm going to come in with the iron tip, and we're going to use the heat, and we're going to suck up all of that solder. Going to get a little smoky, so don't breathe it in. And I'm going to take a Q-tip and we'll clean up all of the flux. All right, so here we are in JCI Drawing. I fold up the iPhone 13 Pro motherboard view. So what we're going to first do is we're going to look at the SIM card tray. And right here we've got our SIM detect tray pin. This is the pin that is responsible for sending a signal to the phone saying, hey, there's a SIM card here. And as you can see, we zoom down on here, this is SIM detect tray, and it is connected through a variety of diodes through to here to this one. And if you look, we're connected to the BB-SIM1 detect. Goes over to this resistor for BB-SIM1 detect, and adjacent to it, this pad that it would otherwise be connected to is BB-SIM2 detect. When we look down on the motherboard, this spot is empty. We'll just see a pad here and a pad here, but nothing there connecting the two. So we need to bridge this in order to get the SIM2 to be detected. When we do that, it'll then actually be able to interact with the baseband. In the meantime, we have to connect a few other things. Up here, you've got the USIM E, and here we've got the BB-SIM2 reset line, and we're going to have to play around with this. We're going to first have to remove this IC, and you can see each one of these components has to do with SIM2, like SIM2 clock connector, SIM2 clock, SIM2 data. So we need to mess in this area in order to actually get the phone to register a second SIM. So on top of replacing the actual SIM tray itself with a physical dual reader that can read two SIMs at once, and using the customized dual SIM tray itself, we will need to connect this line here and make some alterations in this area. So let's go under the microscope and do that. All right, so here under the microscope, you can see in this tiny little area, there are two silver pads here, one right here and one right here. And like I stated, there's nothing connecting them, and we need to connect those two. That way we're connecting the sim detect lines. So we'll get that sim2 to be read. And if we zoom on up here to this area, you can see we have that IC that we need to remove. And then again, we've got a bunch of empty pads. We're going to need to jump these two, this one. We'll remove this resistor and we'll place a 4.7K resistor right here to refine that line. So this IC is gone, and we've got the 3 jumpers and the resistor and a knocked off component there. So first we're going to start by popping off this IC. Alright, so we're going to come in with the hot air. I'm going to see if I can pop off this IC here. Alright, you're starting to see some movement under it. I just want to let go. There we go. We'll pop it off. Make sure that resistor's out of the way. And if you're curious, that right there, that's the size of the resistor that we just popped off. And that's the same size of resistor as far as the dimensions are concerned that we're going to need to put back. So this is a very, very small component. Now what I'm going to do is I'm going to come in with my little wire snips and we're going to cut off a little bit of the end of the wick there. And you'll see I've got a bunch of tiny little fragments of the metal. And I'm going to be using these to connect the different lines. So I'm going to take some flux and put a little bit down in that area. And I'm going to be placing these down there. I'm going to find the ones that I like. I'm just going to leave it in place. Alright, so I like that one. We'll get rid of these. And I'm going to take this one that I like. We'll move it on over in there for a second. I'll line these on up where they go. And we're going to come in with the hot air. And we're going to try to flow these into place, waiting for the solder to melt. See those kind of suck down there for a second, and so we'll add a little bit more flux. Take a little bit of isopropyl alcohol. And that one's on there nice and solid. That one's not moving either. And that one's really good. So those are all done. I'm going to add a little bit of flux here. I come in with my soldering iron. And I'm just going to fluff up those 2 joints that I need to touch with a little bit of solder. Using a little bit of the low melt solder. Make it easier to do this last job over there. In the meantime, let's go over and take a look down in there. Take a small amount of flux on the tip of the tweezer there. Let's go in and make this one work. Come in with the hot air. Line that up where those solder balls are. And just like that, it's snapped into place, and that connection is done. Let it cool down for a second, but it's not going anywhere. Alright, so our jumper's done there, and our 3 jumpers are done there. Now I just need to find a 4.7K resistor. Alright, so now in order to find a 4.7K resistor, I've got this old iPhone 7 Plus motherboard. Most of the older iPhones, you'll find that it has anywhere between 2 and 4 of the 4.7K resistors. So what we're going to do is we're going to go to our JC drawing schematic, and I'm going to type in 4.7, and when we hit enter, we get a bunch of different 4.7, but we're looking for 4.7K. So there's 2. Only 2, alright, and it looks like they're right next to each other. So if we click on this, it'll pull this in, and it's got it highlighted here in red. It's this guy right here on the back. So let's go in and take a look. If we don't have, if this one doesn't work, you can see this resistor is actually connected on both the schematic and board view to the other 4.7K resistor. So these are the two right here that we're looking for next to these two little ICs. All right, so you can see here those two ICs. And we've got one resistor here, and I can actually tell that I pulled this resistor already. So this motherboard, this entire motherboard, with all of these components on this section, under this shield, all of these up here, none of them are 4.7K resistors, just that one. Not this one that looks identical next to it, this one. This is the one I need. We're going to go in there and pull that out and not lose it in the process. Take the hot air to it, hit my tweezers on it. You can see the flux dancing from the previous extraction. And there you can see the solder starting to melt on it when I grab it. So we'll go ahead and lift it up, pull the air away so I don't blow it away, and then I'm going to let go with one tweezer so that I don't accidentally snap it. Because if you keep holding pressure on it, it'll fling off into the distance. So you could let it just stick to one side of the tweezers, and then we're going to move that over to solder it down. Alright, so I'm going to go ahead and gently set it down right there, and I'll spin it into position. If you remember the other one we pulled from here, and we're sticking that one right there. Now I'm going to come in with the hot air and not blow it away, and we're going to let it sit down and relax onto those two pads, and hopefully it'll snap before everything starts to melt, because I added a tad bit of low melt to the pads below it, and boom, it's in place just like that. Alright, so now what I'm going to do is go around the perimeter. And let's add, I'm going to add a little bit of flux to the sandwich layer, and as we do this, it'll make it so we can remove the solder that much easier. I'm going to take my soldering iron with a little bit of low melt on the tip, and I'm going to zip around, adding it to all of the pads. This is going to do two things. It's going to help revive any oxidized pads, and it'll also mix with any of the factory solder. And you can see in this section I actually didn't have a lot of flux, so the solder's kind of just smearing around, versus here where there is flux and it's all staying where it needs to. Kind of push the flux around. So we're just going to go and add some solder to all of these pads. It's okay if it blobs up here and there. We're going to be removing all of it in a second, but I want to make it easy to remove, and I can do that by adding this 138 solder paste to it. And we'll do this all the way around. Okay, we're back to where we started. Now I'm going to take my wick, we'll fold it over. I'm going to take a little bit of flux and flood the wick with it. This will help the solder travel throughout it. And we're going to carefully go and wick up all of the pads. Taking our time, takes only a minute or two to go all the way around. And what I'm also keeping my eye out for is spacers. I want to make sure I remove all of the spacers. I don't want any high points when reballing. They're going to make it so that the stencil doesn't work properly. A lot of them I find stay on the top board. You will find the occasional one that stays down on the bottom board. Start with a new fresh clean wick as we hit the second half. In the home stretch now, there's one of those little spacers right there on the end, little discs. Alright, now I'm going to take some isopropyl alcohol and a Q-tip, and we're going to go around the border and get rid of all of that flux. Alright, now we're going to line it up in the stencil here. You can see I've cut out a section for the 5G antenna so that it doesn't get in our way. And we'll take the iPhone 13 Pro stencil. Before I do anything, I like to make sure I give it a good cleaning. So I'm going to hit it with some isopropyl alcohol, and we'll clean up the back side, make sure it's all good. And we'll clean up the front side. We'll line up the motherboard there in place, and with the pegs that pop through those holes, everything will line up just like that. Now I'm going to take my 150 solder paste and a flat chisel blade. I'm going to grab this solder paste, and this has the dryness that I like it. You can get some that are, you'd have to like dab off and stuff, but this stuff is exactly how I like to smear it. So we'll make sure we've got a good amount of pressure down on the stencil, and I'm going to smear it into all of those holes, and we're going to take our time just to make sure all of it gets filled everywhere and we're not leaving any gaps. You do this under the microscope if you really want to see each one get filled. We'll go all the way around the edges, making sure everything's nice and solid, keeping tension down on the stencil because we don't want to smudge the solder paste under the stencil. We want to keep it where it's supposed to be. And we'll make our way all the way around the border, and every single one of those holes filled with solder paste. And I love reballing without the SIM card tray in the way. Now I'm going to take the cloth and we're going to push down on the stencil. This will kind of force all of the solder paste to make solid contact with the mid frame, and it'll also kind of dry up the solder paste just a little bit more, but this forces it down so that when we go to lift the stencil off, the solder doesn't just come up with the stencil. Just like that. And we'll peel it up just like so, and what it's left is perfect solder paste distribution everywhere. You can see they're slightly off center, but when we go to melt this, and you can see that there's some that are missing, those aren't important at all. Got a little bit extra in this area. I nearly messed my job up just now. Did touch the magnet hold down at this, so I've got to fix that. It's annoying. Grab the stencil, threw it down. All right, right here does concern me a little bit, but that tends to clean itself up when I put it on the hot plate. So there was a little bit of extra solder paste that got through in this top area, but nothing that I'm too concerned about. Let's put this on the hot plate and watch it all come together. All right, so I'm going to set this to 190. I typically don't have to go up higher than that, and I'm just going to hold this by the 5G antenna to transfer it over, and we'll line this up in the stencil there. Peg or two down here, and as this heats up, all of the solder will start to melt and come together and form individual solder balls out of the solder paste. And you can also just give a quick little look at the stencil and see if you've got any solid holes. If you do, then that means you missed some solder paste, but if you've done everything right up to this point, it should all be there, ready to go. Once this is up to temperature, we're going to take it off, let it cool down. I've got to still wick the top board and get this all clean before we put it all back together. And the last thing after that is we'll have to install the dual SIM card reader. You can see the solder starting to form here. It's getting nice and shiny, traveling. It's going from that gray haziness to the nice silver, shiny silver. So this section, this area is done. We still have this area to go. It looks like it's slowly moving its way this way. Nice and shiny. We're hitting about 160. So we know that the majority of this is going to melt around 160. And this, we've got some popping off here. This area, nice and shiny. We're still waiting on the last little bit. And I think we're basically at the point where everything now is melted at about 170. We still need to take it up higher than that when we install the other side, the top side. But in the meantime, this is good enough for us to turn off and take off for now. Let it cool down. We'll set this aside. Okay. And you can see those areas that I was concerned about. There is no issue with any of the solder bridging or anything like that. They're all individual solder balls. None of them stand out as bigger than the others, and all of the paste definitely formed. We don't have any excess or any that didn't melt, so this is good. Just double checking as well on our little jumpers down there. They look nice and solid, and then this one looks good as well. All right, I'm going to quickly go around the border, and we're going to wick up all of the solder on the sides, but in the meantime, or in order to do that, I need to add some flux, and we'll add some low melt solder so that we can much easier have a much easier time wicking it away. Alright, so before this gets too hot, let's go ahead and stick on the lower half and take the top half that's recently wicked, cleaned, and there's a teeny bit of flux applied evenly across all of the pads. We'll set that down, and I'm going to stick that there just to hold it down, and we're going to be watching for this. Take it down, say to 185. I think that'll be perfect to get this to drop, but before it even gets close to there, we need to make sure we line this board up properly. So I'm going to tap it, basically keeping my tweezers flush with the edge till it lines up there. I'll go down and check, and we're going to go back and forth, lining up all of the sides until everything is perfect, and then it'll fall into place. We're going to be looking for a small draw, closing up that gap that's right there along the border. As soon as this gets up to temperature, it should all have dropped everywhere. Start to see it close up soon. We're at 155. There you can see it closing up. No longer a gap there. We just have to wait for the gap up here to close up a little bit more, and it'll do that here as we're approaching 170. But this whole area down here is done. You never want to tap down on it, but you can tap sideways, and we should be at this point with it over 170 soldered. But I'm going to let it get a little hotter just to make sure we're not missing anything anywhere around the perimeter. So we should be getting done soon. And I see zero gap in all sides, so I'm actually going to go ahead and turn it off. We'll gently lift up the peg that's holding it down. I'm going to slowly lift it off of the frame, not to agitate it too much, as that middle section is at temperature. And I've got that now off of the heat plate for a little bit, and we'll let it slowly cool down. And when I'm ready, I'm going to carefully lift this without dropping the motherboard. We'll set it down without dropping it, and boom, let it cool down on the desk. While we let the motherboard cool down, let's turn our attention to the new dual SIM card reader. This can read on the top and the bottom compared to the other one, where you can see it'll just read when the SIM is on the top, but there's nothing on the bottom like this one. It reads both. So what we'll do is I'm going to add flux to all of the grounding points that are anchoring the frame, and we're going to pre-tin them. All right, so we'll come down in here, we'll add some solder, make nice little pillows, just like that. And now we'll take the motherboard. You can see all of the holes got cleaned out except for that one that's against the edge. And that's okay. We're going to come in here, add some flux to all of the legs. I'm going to come in on this one in particular. We're going to add some solder to it, this one as well. And I'm just going to take some time to make sure I mix thoroughly with the factory solder with the slightly lower temperature solder that I have on my tip here. Alright, and this is now prepped as well to receive the new SIM tray. I like to coat the edge of the underside of the plastic of the SIM tray with a little bit of flux. This will actually act somewhat as a heat shield so that doesn't melt because it is exposed over the edge of the frame. Alright, we're going to come in below. We're going to warm up this area, get our tray ready. Alright, looks like we got everything started on the melting, so I'm going to line this guy up. We'll come back in and heat it on up. It'll fall into place. We'll let it cool down, blowing on it a little bit. Now you can see it's nice and flush. We'll let this cool down for a little bit, flip it on over, and now we've got to solder all of those through holes on the back. Alright, so you can see all of the pins coming through each one of those holes. I'm going to add some flux to those holes. You'll see this one's nice and solid. The pin traveled through that hole and is solidified in there, but none of the others have any reinforcement. I'm going to not be using a low melt. I'm going to be using a high melt for this to give it some rigidity. So for that, I need to take my soldering iron way up to 400. And I'm going to come in with the... Oh, and you can see that there's no singeing of the sim tray. That's just a flux. It was completely protected from the hot air from below. That will come in, and you can see how I have to sit here for a second in order for the solder to actually want to travel down into the hole, because it's a high melt, and especially because this is a grounding pad. I'll add solder through these holes on the outside, and we'll just do this all the way around until I'm satisfied with the amount of solder that's traveled through each one of the holes. And it's you kind of have to do it by feel. You can see how much that just clumps up there. The last thing that we need to do on the sim tray area is just clean up the flux. So I'm fairly confident that everything's going to work. So I'm going to go ahead and take the time to put back all of these. Kind of go in reverse order. Sticking that back on, flattening it out. Back the water damage indicator, a little plastic sticker, and then we'll carefully stick back all of the little connector stickers one by one. My goal is always to try not to leave any trace that was in here. Obviously the stickers are a dead giveaway, but those can always be removed. The last big sticker. All right, now let's take our frame, install it back in so that we can test it, make sure everything works. All right, so we'll get the motherboard back in, push down all of the little connectors. And what's really nice about this type of modification is you don't have to worry about doing anything with the software. You've done all the hardware fixes. The battery in the housing, connect up the display, the proximity sensor, and we'll connect up the battery, and we'll go ahead and power it on. Hopefully we see an Apple logo, which we do. It's always a good sign. We'll wait for this to boot up. While we do that, let me grab my dual SIM reader. And now if you look, you'll see that there is a front SIM and a back SIM, which it doesn't do that unless you've properly done the interior correctly. Otherwise, it would just have eSIMs or one SIM. Now we just need to make sure that it populates the information when we plug in SIMs, and then we know that everything has gone perfect. All right, so let's go ahead and take our dual SIM and drop it again, and let's stick it in and see if it pulls up all the info we need. All right, it's in, and now you can see that we've got all of the information, network carrier, everything for the primary and the personal, which is what happens when you put in the SIMs. It pops it into primary personal. So this phone is finally dual SIM compatible. Of course, it needs to go back together, but this repair is complete. And that is how to modify an iPhone so that you can have a physical dual SIM card reader and have a physical personal and business SIM card installed on a phone. If you have any questions, leave them in the comments below. If there's something that you'd like to see in a future video, let me know as well. Thanks a ton for watching. We'll see you in the next video.